of view, where the topic basically of today is iOS Development Survival Guide for the .NET Guy. My name is Nick Landry, and I'm a Senior Product Manager here at Infragistics. You have my email right here if you want to reach me if you have more questions about this webinar. My blog is at activenick.net. That's basically the link that you need to know if you want to be able to get the slides and demos after this presentation. And you can also follow me on Twitter at activenick. So the goal of this session today is basically to teach you how to build applications for iOS, namely the iPhone and the iPad. But everything is explained from the perspective of the .NET developer. So if you're a .NET developer, you've been building a lot of applications in C#, maybe in VB.NET as well. You're already familiar with all these technologies. You know Visual Studio inside and out. But if you've never touched iOS, then you're in the right place. We'll be walking you through basically how to get started with iOS development today. Just to give you a little bit of an introduction about me here. So my name is Nick Landry. I'm known as ActiveNick in the Microsoft community. I'm a Senior Product Manager at Infragistics, and I manage all of our mobile and data visualization tools. I'm a Microsoft MVP on Windows Phone development. So I know it's a little ironic that I'm presenting on iOS, but the truth is, being a mobile developer nowadays is not about being platform specific. The overall picture of a mobile developer is someone who needs to understand multiple platforms. And we're going to be digging a little more about this. So I speak at major events worldwide, and I specialize in mobile development, geospatial systems, and other technologies. Again, my blog is at activenick.net. I will be posting all the slides and demos from this webinar on my blog later this week, and then you can also follow me on Twitter at activenick. So before we begin, I just want to provide a few disclaimers and explain a few assumptions that we made in preparing for this webinar, because I want to make sure that everything is clear and that you're basically in the right place. So first of all, this webinar assumes that you know little to nothing about iOS development. So if you've already been building applications for iOS, if you are already familiar with the basics of Xcode, chances are this webinar might not be exactly for you. You're welcome to stay, of course, but I just want to make it clear that we assume that you know nothing about iOS development, about Objective-C, about Xcode, and about building applications for the iPhone and the iPad. The whole webinar is structured in a way, though, that it assumes that you're a .NET developer. So you're still going to get a lot out of it if you're not familiar with .NET and if you're just trying to get started in iOS. But a lot of the terms are going to be explained from the perspective of a .NET developer. So we assume that you know C# or VB.NET, that you're already familiar with Visual Studio, that you've used technologies like XAML, for example, to build your UI, or ASP.NET or Windows Forms. So they're not exactly prerequisites, but it's definitely going to help the comprehension of the webinar, since a lot of the comparisons between the Mac and iOS world are going to be compared to the .NET world. We also assume that you might know some of the basics on the Microsoft device development side of things. This one is a little more loose. It's not exactly a prerequisite. If you've never done any mobile development before, that's okay. It's just that there are a few comparisons here and there if you are familiar with Windows 8 or Windows RT or Windows Phone development. But it's all good. If you're not, you won't be lost. So everything will be okay. Next, we also assume that you have access to a Mac. This is an unfortunate reality. To do development on iOS, you need to have a Mac desktop or laptop or a MacBook Air or something like that. There are a lot of different options if you don't have a Mac, where you can look on eBay for used machines. There's a lot of used hardware sites also where you can get very affordable machines as well, under $1,000. And also there are options. For example, if you want a brand new Mac Mini, you can get one for less than $1,000. So unfortunately, it's an upfront investment. It's a requirement by Apple. There's just no getting around it. Even some of the other tools that are available on the market to do iOS development do require a Mac sooner or later if you want to test, or if you want to do a build, of course, which you definitely need. There is a simulator that you'll see that comes with the Xcode SDK, but it is highly preferable if you have access to an iPad or an iPhone. It doesn't have to be the latest model. It could be an iPad 1. It could be an iPhone 3GS. It's not a big deal. It's just that it's always a good idea to test on actual hardware, since when it comes to usability, when it comes to performance, these are things that are not easily tested inside of a simulator. And then finally, there are multiple options in terms of building applications for iOS. And this webinar teaches you the native way of building applications for iOS, and that is using the Xcode environment and using Objective-C. So some of the things that I will not be covering, for example, are things like mobile design considerations, how to build a good mobile app. This, of course, could be a week-long or month-long class, so I will not be talking about this. The next thing also is there are alternative methods like Xamarin or Monotouch, you might have heard, allows you to use technologies like Mono and C# to build applications for iOS. There's also another IDE from JetBrains called AppCode, and you can also use technologies like hybrid HTML5 apps that are wrapped with PhoneGap to create iOS apps. These are all viable in their own rights, and we actually have a webinar that we did on Xamarin and Monotouch last week that I'll be linking in my blog. So we definitely encourage you to explore these technologies, but we also feel very strongly that a good iOS developer should at least understand the native way of building an application. So this webinar will teach you how to use the actual Apple technologies without using any third-party IDEs or technologies in order to build your applications for iOS. So these disclaimers and assumptions out of the way, let's just look quickly at our agenda for today. So for today, what we'll be doing is we'll be looking at a very, very quick overview of the Apple world. Since it assumes that you're a .NET developer, chances are you're more familiar with the Windows, the Microsoft world. So I'll give you just a quick rundown of some things that are important to know in the Apple world. Then we'll look at how to get started. What do you need to build applications for iOS? What do you need to download? And what application will you use for this? We'll do a lot of side-by-side comparisons comparing iOS and the .NET world so you can understand the principles. We'll look at how it is to develop in Xcode versus Visual Studio. So Xcode is the development environment. And then we will be building a very simple demo application in this, where you'll get a chance to see what is the experience like, what kind of code can you write, and how does Objective-C look like compared to C#. And then finally, we'll look at a couple of other things like user interface controls that you can use and different libraries that are available to iOS developers. We'll have a very quick overview at the end of iOS 6, and then hopefully we'll have some time for a Q&A. So we only have an hour for this webinar, so hopefully there's going to be a time at the end for the Q&A. I'm okay sticking around a little longer to answer questions in the GoToWebinar interface. I also have my colleague Brent Schooley. If you want to follow him on Twitter, it's bschooley. And Brent is one of our evangelists here at Infragistics, and he will be available during the webinar to answer your questions along the way, so that at least we can get some questions answered before the end of the webinar. But as for myself, I won't be looking at the questions until the end. Now, the first question you might ask yourself is, why would you build applications for iOS? Because iOS, as we know, is the Apple platform, and Apple is a force to be reckoned with in the mobile world. Everything was completely changed about 5-6 years ago when the iPhone was introduced, and then a few years later after that, we had Android that was introduced. So now when we look at the smartphone options today, the market is heavily dominated by Android and by Apple. However, if you've been following some of the news and some of the market share reports, you'll see that Android actually has an edge over Apple in that Android has a larger market share worldwide than Apple, and that's especially true worldwide, but also the case in the US where Apple is the strongest. However, we need to understand that it's not just about market share, it's also about the type of user that you're getting. The Apple user is used to buying a premium device. So these devices are usually a little more expensive. They're not part of the free phone options whenever you go see a carrier and renew for a new account for a couple of years. So what that means is that the actual users will be maybe more prone to buying applications. So a lot of stats have been coming out, and some of those stats show that the revenue on the iOS side is anywhere from 4 to 6 times higher compared to Android, despite the fact that Android has a larger market share. So iOS is definitely a platform that is that can be quite lucrative. Of course, the competition is much higher. There's over 700,000 applications in the iOS App Store. So definitely there's companies that have been going all in, and that's usually the first platform that companies will support whenever they build a mobile application. Beyond that, there's other technologies also like Windows Phone. There's BlackBerry, just announced the new BlackBerry 10 recently. So, of course, the mobile world means that you have to understand a lot of different technologies. You can't just call yourself a mobile developer and only know one platform. It's usually a good idea to know at least 2 or 3 of those platforms to cover a wider range, but also to understand the considerations of all those users. Another option, of course, is some people will be using HTML5, and what they'll be doing is basically create an HTML5 application, use technologies like PhoneGap to wrap this application in a native app, and then publish that application on multiple platforms, to the Apple App Store, to Google Play, to the Windows Phone Store, and the BlackBerry app world. So while it's a very viable option for certain scenarios, if you're looking to really be competitive in the market and to create an experience that your users will remember and that your users will keep coming back for, you definitely need to learn the native way of doing things. That's why we're teaching you the native way of building iOS apps today. And also in 2 days, I will be doing a webinar on the Windows Phone side of things, so you'll be able to come back for this. I have a link at the end of this deck. In terms of the Apple world, just to give you a quick overview, so smartphones are not new. Smartphones were basically introduced in the late 90s, early 2000s, depending on your definition of a smartphone. Some of the names that were dominating back then were actually Windows Mobile, Palm, BlackBerry. But now, of course, in 2007, iOS and rather the iPhone was introduced, and that's when everything changed. So the iPhone OS was announced in 2007 in January, and then 6 months later in June, the iPhone version 1 was actually launched. The thing is that a lot of people don't remember is that there was actually no App Store back then. So the approach that Steve Jobs wanted was to primarily focus on mobile applications because he didn't really believe in giving control to developers. But after a few rogue app stores started emerging in the first year of the iPhone, then Apple decided to launch a beta in March 2008, and then a new App Store was launched a full year after the initial introduction of the iPhone. A few years later, the iPad was basically modeled after the iPhone and used the exact same operating system. And that's at that point that Apple realized, well, you know what, this operating system, we can't really call it the iPhone OS because it also runs on the iPad, so let's call it simply iOS. The devices today that support iOS include the iPhone, there is the iPod Touch, there's the iPad, and also the iPad Mini. The Apple TV at its second generation also uses iOS, but it's a little less relevant for you because you actually don't really have the option of building your own applications on the Apple TV. The latest iOS versions that are available on the market that you're probably going to see as a developer, there's actually a fair amount of iOS 4 out there still, but the majority of users will be running either iOS 5.1.1, which was introduced in spring 2012, or iOS 6, which was introduced in September 2012, and then in January came iOS 6.1. I have a few details later about some versions of iOS, but it's important to understand the different versions out there, especially when there are specific features you want to take advantage of. One of the key features that was a big controversy actually around iOS 6 was Apple Maps. The fact that the Google Maps SDK was removed from the map kit and it was replaced by Apple Maps, and that's something that came in iOS 6, and that's also one of the reasons why a lot of users are still hanging on to iOS 5 because they want to stick to the original Google Maps. Now, in terms of iOS, where does it come from? So it's not an operating system that was built from scratch. It's actually an operating system that was loosely based on the Mac OS X itself. And as an Apple developer, as a Mac or rather an iOS developer, you're going to be playing a lot with Mac OS X because Mac OS X is the operating system that's going to be running on your Mac machine that you'll be using for development. OS X itself is based on Unix and NextTech. So Next was basically a technology that was developed by the company NextStep, which is a company that Steve Jobs founded after he left Apple in the 80s, and eventually which was purchased back by Apple in the 90s, which is why Steve Jobs came back to Apple. The Mac OS X was basically, or rather the Mac OS was completely rebooted in 2000 with a beta version, and then in 2001 came the original release of Mac OS X. Ever since, what we've been seeing is Mac OS X seeing these incremental updates, 10.1, 10.2, where the X is the Roman numeral for 10. And version 10.0 was named Cheetah. That's when Apple started this trend of calling their operating system versions after naming them after big cats. So the original release was in 2001, so it's already 12 years old, and that's when the new Mac OS was introduced. Back then, Macs only ran on PowerPC CPUs. The first version was considered to be a little slow and incomplete, but it was also a big milestone in rebranding and revamping the Mac world, the Mac technologies. A lot of new operating systems came out after this, so there were several revisions. And then during that time, Apple slowly transitioned away from PowerPCs and into Intel CPUs, namely in versions like Tiger and Leopard. That when you started seeing Macs running on Intel CPUs, that's when you started seeing people sometimes running Windows on a Mac machine because they love the hardware, but they wanted to continue running Windows. In 2009, Snow Leopard was the very first version to only support Intel CPUs. It was much better, introduced new technologies like the Finder, which is kind of like the Windows Explorer on a Mac, a better Safari web browser, and that's when also they started taking some of the success of iOS and bringing it back inside of OS X. So whereas the iOS App Store was extremely successful after its introduction in 2008, then Apple decided to take this App Store approach and then bring it over to the Mac in 2009 with Snow Leopard. In 2011, Lion was introduced. This one only supported 64-bit CPUs. The Rosetta technology that allowed you to run the old PowerPC apps on an Intel machine went away, so at this point it was only Intel-based applications, and introduced better things like multi-touch, application resume. So a lot of the technologies like we see on tablets, the fact that we don't have to save our documents, we don't have to really think of an application as in quitting an application or starting it. It's always there. When you bring it back, it comes back to the state it was in. A lot of these things started showing up in Lion. The Launchpad is basically an interface that kind of looks like I know I can probably show you here, but if I go to the corner, so you can see here, this is Launchpad. It basically looks like an iPad application, but in fact, it's just a way of launching your applications, of seeing all your different icons on your Mac, so that it looks a little bit like an iPad. And there's also Mission Control, which is some kind of a dashboard where you can put a bunch of widgets to configure like a quick look at different information, whether it's stocks, weather, and things like that. Mountain Lion is the current version of the Mac OS X operating system. It introduced more things from iOS, like the Game Center, which is Apple's equivalent to Xbox Live. And then you also have iMessage, which is their message transport that doesn't rely on SMS. They introduced also a notification center, so you can receive push notifications on your Mac. And iWorks now works iWorks basically supports documents in the cloud, so in iCloud. So there's a lot of other features in these operating systems. I just wanted to give you a very quick overview, and now we're going to start digging into the differences between Windows and iOS in terms of as it is for a developer. One of the first differences that you will notice whenever you're looking at a Mac versus, or rather at an Apple device like an iOS device like an iPad or an iPhone compared to the Windows world is that it's basically very different in the sense that the Apple world was very strong on what we call Chrome. So there's a notion in user experience circles that's called skeuomorphism, which is basically taking a real world object and creating a digital version of it on a computer. So for example, if we look at iBooks on the iPad or the iPhone, you have this notion of a bookshelf that appears to be made of wood with actual shelves where the books are resting on, and you see shadows and things like that. This kind of notion is very Chrome heavy. And that's something that's been very popular in Apple circles. People love that look and feel, but it's also very different than the Microsoft approach, if you're familiar with this now with Windows 8 or Windows Phone, which is originally called Metro or Microsoft style. And it's an approach that's much more focused on content, so things are going to be much more flat, but it's dynamically going to show you more information. So the launchers on iOS are considered to be more static launchers. They don't tell you much. On the Windows side, things are a little more flat. Some people criticize the Microsoft look for being actually a little too boring sometimes because everything looks the same, but the idea is to show you a lot of information at once. So both approaches have their own merit, and that's also why it's very important as a mobile developer to understand that you can't just design an application for one platform and immediately just port it as is to another platform, even if you can translate the code. The idea is that you need to design an experience that's going to feel at home on the device that you're targeting so that your users will not feel like they're using, for example, an Android application on an iPhone or a Windows application on an iPhone or an iOS app on a Windows phone or things like that. So a good developer needs to understand the platform they're building for, and that's why as a mobile developer, it's really important to familiarize yourself with multiple platforms. So now let's get started. How do we build an application for iOS? Well, the first thing you're going to need is, as a computer, you're going to need a Mac. So today, you're probably using a Windows PC or laptop, but for iOS development, you're going to need to use a Mac. Your development operating system today might be Windows 7 or Windows 8, but as an iOS developer, you're going to be using Mac OS X. So even though you can technically run Windows on the Mac machine, that still won't allow you to basically create applications for iOS running in Windows. You need to have the Mac OS X, and unfortunately, you can't really take the Mac OS X and run it as part of a virtual machine so that you can run it, for example, in VMware on Windows. Apple has kind of technical blockers to prevent you from doing this. There are ways to basically hack your way to make the Mac OS X run on Windows, but it's not going to be a great experience. You're going to run into a lot of issues, and things are just not going to be able to be easily maintainable. So the bottom line is, if you want to do iOS development, you will need to have a Mac sooner or later. And even if you use other technologies like PhoneGap or Xamarin, you will also need a Mac, because those technologies do not allow you to actually build your application. You still need a Mac for that. Your official resource as a .NET developer is to use MSDN, the Microsoft Developer Network. For iOS developers, you will go to the Apple Developer Center. In terms of your IDE, the development environment, you're using Visual Studio today probably, and you will be using Xcode. That's the name of the development environment provided by Apple, which is free, by the way, and then you can install this on your Mac. The development languages, .NET supports multiple development languages, so you can use C#, VB.NET, F#, or any of the many .NET languages that are available, whereas as an iOS developer, you will be using Objective-C. So Objective-C, maybe you're not familiar with it, maybe you haven't tried it yet. Basically, back in the 70s and 80s, when the C language was the main thing around, C became object-oriented, and the C language kind of split off into multiple versions that were object-oriented. The primary version that most people are familiar with is actually C++. That basically gave classes and object orientation to the C language. However, C++ is not the only object-oriented version of C. Objective-C is probably the second most popular one. And in fact, due to the sheer number of apps that have been built for iOS today, it's been said that Objective-C is now the most popular language in the world. So not a bad thing to learn. And next, in terms of the primary SDK that you'll be using, as a .NET developer, you're actually using the .NET framework, and then you might add additional SDKs on top of that, like the Windows Phone SDK. As an iOS developer, the SDK is simply called the iOS SDK. The term framework, be careful not to be confused by it, because the term framework in the iOS world is what you would call an assembly in the .NET world. So when you add different SDK libraries to your project in Visual Studio, you will actually add different DLLs that are called assemblies. Whereas in the iOS world, those additional libraries that you can use are actually called frameworks. So when you see the term framework in iOS, don't be confused, because it's not the same thing as the .NET framework. Now, this code, how is it going to be compiled? As a .NET developer, you're probably familiar with the principle of managed code. Managed code simply means that your code is first compiled into an intermediate language, into IL, and then at runtime, that code is then managed by the CLR in the .NET world. And the CLR is your runtime, and then what it does is it just-in-time compiles, it JIT compiles your code into machine code, which is the native code of your CPU. The good thing about the CLR, of course, is it provides a lot of additional services to make sure that your code is safe, secure, that it also provides services like garbage collection to make sure you don't have any dangling pointers that can cause memory corruptions. On the iOS world, you don't have any of that stuff. It's basically native code. Your Objective-C is compiled directly into machine code that's going to run on your CPU. There is no runtime, even though the compiler tries to provide a few services that are kind of like the ones we find in a runtime. We'll look at that. but as is, it's just like C++. What you're building is something that is native without additional services at runtime. In terms of the user interface, if you're a WinForms developer, you're using a native interface for WinForms. If you're a WPF or a Silverlight developer, you're familiar with XAML, which is the markup language for Silverlight and WPF. On the iOS side of things, your user interface is actually going to be created using Cocoa Touch controls. You can actually create them natively in code by writing instructions to create the UI, or you can use something called the interface builder, which is included in Xcode, and we're actually going to be looking at this in our demo very shortly. In terms of your operating system targets, the .NET world, that's where the story kind of breaks down, because today Windows 8 and Windows Phone 8 kind of share a common core, but unfortunately they're not exactly compatible. So you can't write an application for Windows Phone and then expect it to run it on Windows 8 or vice versa. So creating applications for both Windows 8 and Windows Phone, it's something that it kind of looks similar, but you're still going to have to do a lot of the work twice with maybe a little bit of code reuse between the two, but it's still a lot of work. On the iOS side, it's actually a great story because you can write an iPhone application with Objective-C and your iPhone application will run as is on an iPad. Sure, it's going to look smaller on the screen, or you can blow it up so it looks twice the size, but at least it will run. And you also have the notion in an iPad project, an iOS project, of creating what we call a universal app. And universal apps are apps that basically will have two kinds of views and a common core, where one view would be for the iPhone, one view would be for the iPad, and then you would have a lot of shared code between the two. Something that we do not have on the Windows 8 and Windows Phone side of things. How much does it cost basically to get started with this? Well, technically, to get started, it doesn't cost anything aside from probably needing that Mac machine I've been telling you about. But when it comes to the actual developer program, if you want to start submitting applications or testing on actual devices, you need to be a registered developer with an active subscription in a developer program. So on the Windows side of things, again, there are two separate programs, one for Windows Phone at $99 a year, one for Windows 8 at $49 a year. There's easy ways to get that discounted by Microsoft in various contests and programs, but still, it's two separate costs. It's kind of inconvenient. Whereas on the iOS side of things, to be a registered Apple developer, you just need to pay $99 a year, and then that allows you to build applications for the iPad, for the iPhone, even for the Mac as well, or Safari apps using HTML. And then finally, in terms of the target devices, once you've built that app, where are you going to send that application? Well, that's where on the .NET world, the story is a little better because, of course, any kind of PC can run any kind of Windows 8 app as long as they're running Windows 8 or Windows RT. There's a wide range of manufacturers that actually support these technologies. Same thing with Windows Phone. There's multiple OEMs that build devices for Windows Phone. However, on the iOS side, you can only run things on Apple devices. Granted, those Apple devices have a very, very good market share, so at least it's a great story there. But it has to be an iPad by Apple or an iPhone by Apple, and nobody else makes compatible machines. Okay, so enough talking about the comparisons. Let's start digging into the development environment to see what it looks like. So instead of showing it to you on a slide deck, what I'm going to do is jump directly into Xcode. And then what I'm going to do is right here at the bottom, you have your bar that shows you all your different applications that are running. Hopefully this is coming across well over the webinar software. So you come to Xcode right here, you launch Xcode, and in order to get Xcode, by the way, you would get this from the Mac store. So on your Mac operating system, the moment you're running Snow Leopard or higher, you then automatically get the Mac App Store, and then you go search in there and you'll find Xcode. Xcode is a free download. However, depending on the last version that you'll be installing, you're going to need the latest version of the operating system. For Xcode 4.4 or 4.5, Lion is enough. But if you don't have Lion, I think it's actually a cheap upgrade. It's something like $20 or $30 to upgrade from Snow Leopard to Lion. The last version is Mountain Lion, but I'm actually running Xcode 4.5 here, and I'm not even running Mountain Lion on this machine right now. I'm still running Lion. So When you start Xcode right here, you get the option to create a new Xcode project, or you can access one of the recent projects that you've done. So I've done this presentation in a number of cities, as you can see. So there's also a lot of references you can go to. You can jump directly to the developer portal. But for now, we're going to say we want to create a new Xcode project. So Xcode is going to be fired up. And just like Visual Studio, Xcode presents us with a number of templates that we can actually use. So those templates are kind of starter projects, and you pick the one that's going to match more closely with the kind of application you want to create. So it could be a master detail kind of application where you would have a list, and when you select an item in your list, it shows the details for it. It could be an OpenGL game. So if you're creating more of an experience around a game loop type of application, if you're familiar with game development, you would pick this. It could be a page-based application where you can have multiple pages that are going to be tied to your controller, and then you can also use the single view application, which is the one we're going to pick today. If you're really hardcore, you know where you're going, you can go with an empty application. You can go with a utility application if you want, and then where you can have like a main view and an alternate view, and then there's also the tabbed application that you can start with. Of course, you can then take any one of those and then go from there with different controls and create any kind of UI. So the simple one to get started, of course, is a single view application. So we're going to select this for now. And then in our single view application, the first thing we need to provide is a product name. So what kind of application am I going to create today? It's actually very simple. Think of a little flashcard application. So I was traveling in Europe last summer, and I was basically playing around with iOS development, and I thought, since I was in Italy, hey, I don't speak Italian, so maybe I can create a little flashcard application to basically help me train myself and remember Italian sentences. Unfortunately, I didn't have anything done by the time my Italy trip was over, because you can imagine I was not just writing code the whole time. But I figured, hey, I'm going to Spain in November, so let me write a little Spanish quiz application that allows me to basically query myself and test myself using a flashcard approach. So it's a little quiz app, so I'll call it simply Webinar Quiz right here. And then you have to provide an organization name. The organization name is basically going to be used to create your bundle identifier. You see here that I have Webinar Quiz and then organization name, and my bundle is called net.activenic.webinarquiz. So for example, in this one here, I can say I'll call it Infragistics, since that is my organization name. So now my my identifier, what I'm going to do is change it to Infragistics right here. You kind of make sure that it matches. And then once it's created, that becomes my unique identifier. It's a good idea to use your domain as your company identifier in reverse like this, because this way, since you own your own domain, then you know that your bundle is not going to conflict with anybody else's bundle name, because this has to be unique in the store. The next thing you have to pick is actually a class prefix. So as a .NET developer, you're not really used to this notion of class prefixes, because the class prefix is something that every single one of the classes in your project will actually have that prefix that's going to be appended at the beginning of your class name. So the reason for the class prefix is actually because of name collisions. It is highly likely that you can create a class name that maybe another developer or another library is already using. So normally as a .NET developer, we avoid naming collisions like this using namespaces, because even if you have two classes of the same name, as long as you enter a fully qualified name for the namespace where that class resides, or if you have a using statement that says which namespace that class should be basically referring to, then namespaces save you from this and you don't have any collisions. Prefixes, unfortunately, it's not as elegant as namespaces. Namespaces don't exist in the Objective-C iOS world, so you have to use a class prefix. So for this one, we'll just call it quiz, and that's going to be part of our class name for everything. The devices you can pick from is going to be either iPad, iPhone, or Universal. The Universal is an app that will be able to run on both. The beauty of Universal apps, by the way, is that if you're an app developer and you want to create something that's going to work on both, instead of creating a separate iPhone and iPad version, which is a lot of the same techniques as a Universal app, the beauty is that your users will actually thank you for it, because once you buy the iPad, the universal version of an app, it is available on both machines. So if you sell your application for $1.99 or $2, and then you post your application in the App Store, and then somebody on an iPhone buys your application, then later, if they also have an iPad, then they can actually reinstall your application on the iPad, and then from there, don't have to pay again because the App Store knows that this is the same application. Well, you might say, well, you know what? I'm not going to make my money twice this way. I'm just going to make it once. But trust me, the good apps now are using that model. Users have started to expect it. And when you have to compete with another 700,000 applications out there, it's good to give a little more to your users to entice them to basically buy your application. Storyboards are out of the scope of this webinar. It's basically a way that you can create an application that's going to have multiple views, and then you can jump from one to another and control the flow of things. This is beyond the scope of this webinar since we're just going to be using a single view here. Automatic reference counting, I will get to. It basically allows you to do more simplified memory management. So since there's no runtime here, the compiler will insert code to make sure that it basically recovers some of the objects that you've created if you haven't manually done so in your code. So it's kind of a little bit of a garbage collection, but it's done by the compiler at compile time, and it allows you to save you from errors in memory management. You can include unit tests, but for the scope of this webinar, we're going to skip that for now. So I'm going to click Next, and then my project is going to get created. It's going to ask me where do I want to put it. So I'm going to say put it in my development folder here. And then Xcode is going to create my project. So let me maximize this here. So we take the full screen. All right. And then in this view right here, what I have is the Xcode development environment. Now, the first thing when you look at this, you'll see that you have your project navigator right here on the left. Normally in Visual Studio, we're used to seeing this more on the right. So some of you might have the reflex of saying, hey, you know what? I'd like to take this and maybe move it over to the right. Unfortunately, that is not possible. The layout of the windows here is actually fixed. You can resize stuff like this, as you can see, but you cannot move the windows around. That layout is actually fixed. So the experience of development on iOS, it's not entirely bad, but I have to be honest with you, Visual Studio is definitely more of a premium experience. So your project navigator here actually shows you the different files inside of your project. And then as your project here, you have a target. And the target basically specifies where will you be deploying this application. So you can say the target here is going to be an iPhone. You can control the version number. And then you can specify storyboards if you use them. In this case, I'm not going to be supporting landscapes. I'm just going to skip those completely. And then you can say if you want to show the status bar. And then you can also set a launch image. The launch image is basically the first image that is shown right when you launch the application. So some people will use it as a splash screen, but of course that splash screen might show up a little too fast, and it's kind of going to confuse your user because they're not going to be able to see it long enough. Typically, the launch image, you're supposed to put an exact replica of the very first view of your application, maybe without any data, so that it gives the illusion that the application is already loaded. So it's kind of a little bit of a perceived performance trick that is done on Apple, on iOS, and that's why iOS applications usually give the impression of launching very, very fast. You would be able to set your app icons right here, and then you have a lot of build info and build settings that you can control as well, although we don't really have time to dig into those right now. So you'll notice here we have a whole bunch of files in our project navigator. So we have an app delegate, and then we have a QuizViewController. So you notice the file, the prefix quiz appears on every single file. So why is that? So the app delegate itself is for the application itself. It's your main class for your application. But now, since we want to focus on building an actual view, you basically need to start populating this view with the controls and then the code that's going to go behind it. So typically, you would be greeted by a form if you were creating a XAML application. You would have a XAML file, and then that could look maybe a little bit like this here. So we have the interface builder. So that's an an environment that allows you to drag controls, which are at the bottom here, to create your user interface. However, the next thing that you see here is a .m and a .h. That's because just like C and C++, you need to separate your header files from your implementation file. So the .h is the header file, and the .m is the implementation file. However, you might ask, so why is it that I have a view controller that was added here automatically? Well, that's where it's a little, I would say, not inconvenient, but Apple has decided that the MVC model, MVC pattern in terms of structuring your projects is mandatory on Xcode. So that means you can't just create a little hello world, drop a button, double click on it, add some code, and run it. You basically need to create a view controller, and you need to wire up your view to your view controller. And that is how every project in Xcode is going to be created. There are ways that you can get around this, but it's going to be more work to avoid MVC than it is to use it. So you might as well just go ahead and use it. And it's not a bad practice to use after all. So learn about MVC if you don't know it already. Most iOS books will teach you about it anyways. And today you're going to see some of the basics on how to get started with this. So let's start writing some code. So the first thing we need to do is to go inside of our QuizViewController.h, and then we have an interface right here that derives from UI ViewController. And then the first thing we need to do is to start building the header file for our main view controller. So the first thing we need to add here is, let me just close that brace right now so I don't forget about it later. So the first thing we're going to need is we're going to have a series of questions, and when we go through these different questions, we want to be able to keep track of which question we're on. So I'm going to go int and then say current question index, index right here. And then the next thing we need is we need two arrays. One array is going to be for questions, and another array is going to be for answers. So ns mutable. You see we have this little pop-up here that kind of looks like IntelliSense. So you can either press tab or enter to actually get to the next step. And then we're going to use, as you can see here, this is an actual pointer. The star is to indicate this is a pointer because we don't actually use objects in this. We use pointers to objects. So we have ns mutable array. And then this is going to be answers right here. Then the next thing we need is, since we're using a view controller, we have to wire up our view with the controller itself. So for this, we basically need to make sure that our view is our controller is familiar with the different objects that we'll interact with on the view. In this case, it's going to be two labels. So these are done via outlets. So we say IB outlet, and then it's going to be a UI label, and then it's going to be called question field. So we're going to have one label where the question is going to show up in our flashcard, and then another label where it's going to be UI label, and then it's going to be answer field. Whoops, little typo here. Okay, so that's for our main interface. The thing though is that whenever we're going to click on one of those buttons, because we're going to add a couple buttons on our view, we want to make sure that we can actually wire up our those actions from the view over to our code. So I did things a little direct here because I know exactly what I'm going to be building. So that's why I did it directly in code here. But we could actually have built our user interface first. So let's do that. Let's just go to the view controller here. And we have an XIB file or a zib file. The zib file is basically an XML representation of a nib file, which is the compiled version of your UI that shows up in your app bundle. And this is where you create the user interface. So let's create the user interface really quickly. We're going to drag a couple labels here. So I'm going to put one label on the form. And like this, we have nice little guidelines, kind of like the latest versions of Visual Studio, to allow us to create something a little nicer. And then I can actually come and inspect the properties on this here. So this is the attributes inspector right here at the top. And then I can say that this label, I'm simply going to type it, and I'm going to leave it empty for now. And it's going to be centered. So the text is actually going to be empty. And I'm going to put a button underneath like this, snapped nicely. And then my button, the text is actually going to be called show question, like this. Then I'm going to drag another label down here, align it there, Okay, and then on this one, what I'm going to do is also center it. I'm going to put a few question marks on this because we don't know what the answer is yet. And then we're going to drag another button underneath from the toolbox. And then, whoop, there we go. And this one is actually going to be called Show Answer. There we go. So we have two labels, we have two buttons. So if we come back to our interface on our ViewController, we know that we have two labels right here. One is the question field, one is the answer field. And then what happens whenever you click those buttons? Well, you can't really double click. Like in Visual Studio, you would simply come here, you would double click, and then expect to jump into an event handler. That's not the way it works in Xcode and Objective-C. All it allows you to do here is basically to edit the button label. So the way to do this is, first of all, we have to create an outlet, which is where whenever we press a button on the view, it basically needs to call the proper action. Sorry, not an outlet. It needs to call an IB action inside of the ViewController. So when I come here in my code, what I'm going to create is an IB action like this. And then, actually, I had a nice little template that was built for me automatically, but I'll just type it manually. So I'll just show question, ID, and sender like this. And then I have another IB action like this, so I can press tab like this so I could keep the same tag. That's why you saw me type it manually before, but now it's actually pre-populated for me. And this one is going to be called Show Answer. And that's it. And then let's add our semicolon at the end. So now I have two actions that whenever I'm going to click something on the view, it's actually going to call those actions. But now nothing has been wired up. I've created the interface for my ViewController, the header file, and I've created the user interface itself. But now I need to wire them up so that the ViewController, whenever I change the label in code, it's going to go and change the label in the view. And whenever I click a button in the view, it needs to fire up the proper action in the ViewController. So to do this, what you do is you come right here to the file owner. The file owner is basically the ViewController. And all you need to do is basically to right-click the file owner right here, and then you'll see there's a bunch of outlets. So there's an answer field. I apologize if this is a little small on your screen, but there's an answer field and a question field. These are the two outlets we've already created. So the question field, I simply drag this, and I go and I connect it with my question field. And the answer field, I go and drag it and connect it with the answer field right here. Next, I need to be able to basically take this button right here, and whenever I click on it, I need to be able to tell it, go start the proper action in the ViewController. So all I have to do here is to basically right-click. You can't see my right-click, but I'm right-clicking the Show Question button right here, and then I'm going to drag, and I'm going to go and drop on the file owner, and then it shows me the two events, which are the two actions that are available here. So the first one is Show Question, and then the second one is right here. It's called Show Answer. So now I've wired up my view and my ViewController, and that's how you create an interface with quote-unquote code behind inside of Xcode. So if you want to review those connections, you can actually click on your files owner right here, and then you could look at the connections inspector right here. It shows you all the different outlets, answer field, question field. It shows you dynamically in the UI. And then it shows you the received actions where Show Answer and Show Question are tied to the two buttons that we have here. I'm going to jump forward here. I'm just going to save this project. I'll make all the source code available to you because we're running behind anyways. We only have about 10 minutes left. I want to show you this project in action. So I'm just going to switch over to a recent project, which is the completed Spanish quiz. So you'll get to see it in action. So this one here, as you can see, the QuizViewController is exactly the same as I had. My two arrays, my two outlets, my two actions. The user interface looks exactly the same, except that instead of show questions, show answers, I say, how do you say this? And then show the answer in Spanish. And I have my two labels that are right here above and below. So the code, in terms of implementation behind this, we can go look at the QuizViewController. This is code that I've pre-written here to save us some time. So if we look at the initialization here, so this is where the class gets initialized. I have two arrays that are being created here. So I have my questions and my answers in my header file. And we use the alloc and init keywords to basically create the allocation in memory and then initializing this array so we can start using it. And then the syntax to add strings to these various arrays. So I say questions here dot add object, and then I add hello, good morning in English, and how do you say this in Spanish is hola, buenos dias right here. So then I basically populate my two strings, my two arrays with various strings that are all paired up in the same order. And then finally at the bottom here, whenever I want to show the question, so if I press the button to show a question, then I simply say I increase my question index. If I'm already at the end, so if I'm already at a count of questions in my NS mutable array, I reset it to 0. And then to extract the question out of the array, I simply say object at index, current question index, and then I set this inside of an NS string. The NS log is kind of like the debug window, the debug output that you have in the Visual Studio. And then my question field, that's part of my ViewController, I simply set the text to question, and in my answer field, I set the text to question marks. Same thing with the show answer. I basically extract it and I set the answer. So as you can see here, we're actually not touching the view itself. We're touching the answer field and the question field in our ViewController itself. And then since our ViewController is wired with our view, this is done automatically for us and everything will show up. So I'm just going to run this project right now so you get to see it in action. So I'm going to click run. It's going to say build succeeded. And then what it's going to do is launch the iOS simulator. So let's just give it a second here for the iOS simulator to show up. There it is. So the iOS simulator is initialized. It looks like an iPhone. And then I have a little application here where I say, how do you say, how are you? And then I'm thinking, how do I say, so it's como esta. So yes, it's como esta. And then how do you say, yes, please? And then you basically, the answer would be sí, gracias, I think. Yes, sí, gracias. So it's a little flashcard application, pre-programmed phrases. How do you say something? No, thank you is going to be no, gracias. So that's a little simple application that helps you to get started. Of course, you will want to go much further with this. This is nothing more than one step above Hello World, if you will. So I'm going to go back to Xcode. I'm going to stop my execution on this. Let's go back to the slides. And then let me just wrap up a few things because we only have 10 minutes left. And I would love to be able to tell you a little more about all of this. So that was our demo. And in terms of development IDEs, I've already mentioned a lot of these things during the demo. Both use templates. What we call a solution is called a workspace in iOS. Both use the term projects. Your class files are in CS files in Visual Studio. They're going to be in .h header files and .m implementation files in Objective-C. Design patterns, you can use whatever you want in .NET, but you kind of have to use MVC inside of Objective-C Xcode projects. We use namespaces in .NET. iOS developers use prefixes for their classes. The device emulation is a bit different. .NET gives you a true emulator that actually emulates the hardware itself, whereas iOS basically gives you a simulator. It kind of simulates the environment, but it's not actually going to be a true simulation of the hardware chip underneath. Application packages, Windows Phone and Silverlight use Zaps. Windows 8, Windows Store uses AppX. iOS using the .app, which is a bundle. And then you cannot rearrange the layout. Source code control, you don't have as many options as Visual Studio. You can only use Git and SVN, subversion. This is just a little comparison of two code snippets. You'll be able to access this in your in the slides when you download them from my blog. But basically that shows you similar syntax as you would have it on the left in C# and how it would be in iOS as an Objective-C developer. In terms of the different frameworks, so just like you would add a lot of different namespaces and different assemblies to your project inside of Visual Studio, you can add different frameworks, which are these kind of libraries that you can use inside of your project to do more advanced functionality. All of the base, foundation, and core data classes are going to be prefixed with NS, and all the 2-letter codes that you see everywhere here, that's basically the name of the class prefix for all the classes in those different frameworks. So the beauty of prefixes, though, is that whenever you see a class, it's very easy to know right away which library or which framework it comes from. Whereas in Visual Studio, you have to go and hover over that class name and then inspect the namespace to understand where it comes from. So you have a lot of different kits, like things like the UI kit, that's where UI controls come from. The map kit is for the Apple Maps SDK. It allows you to put maps in your app. Event kit, an event is a calendar item, by the way. It's like an appointment. Game kit is for game sessions. iAd is for advertising. Message UI, it's like text messaging, but it supports the iMessage format. You have address book to access the contacts in the address book in the iPad or the iPhone. Twitter also has its own framework. It's basically to help you with authentication. And then there's a whole lot of other frameworks that are available here. I couldn't put all of them on screen. Like there's 16 frameworks just for media, things like core graphics, core video, core image. These are all self-explanatory. You also have 17 different frameworks in the core services layer. Things like the various accounts in a device, network, core motion, system configuration, and then you have the core OS layer, which includes things like Bluetooth, security, and external accessories. So we're coming up on 4 minutes to go, so I'm going to try to go a little faster. As I explained, there's no CLR here, there's no runtime. So what Xcode can do is when you activate automatic reference counting in your project creation, and you definitely should, what Xcode will do is insert, retain, and release code for you so that if you forgot to basically free up some objects, then at least Xcode will try to insert those statements to prevent you from having dangling pointers or loose orphan objects. Other comparisons between the two here, so we use references to our objects, whereas on iOS, everything is based on pointers. It's a very big difference because you're actually pointing to the memory space. So if the object moves to a different memory space, your pointer is not pointing to the object's new location. You're pointing to the actual memory space, which could have something else. The new keyword is used to create a new object. We use alloc and init on iOS, although new has been introduced as well, but the traditional way is using alloc and init. And then there's a few other differences like constructors versus initializers, method calling versus message passing, relational storage, you're going to use SQLite. There's iCloud for storage in the cloud as well. And then in terms of mobile deployment, I've already covered a lot of this already. The story is actually much better on the iOS side of things. However, when it comes to side loading, using a Microsoft device like a Windows phone, you actually unlock the phone using your developer account. So that means that once the phone is unlocked, you can sideload a whole bunch of different applications, whether you built it or whether somebody else built it. It's very convenient, but it's a little more open. On the Apple side of things, you actually have to unlock at the application level. So what that means is that at the application level, you basically need to provide the UDID, which is the unique identifier of each device where you will deploy this application. So you need to know in advance who are going to be the people that will be testing your application. It's a little more inconvenient. There are enterprise accounts that are possible that are more expensive that allows you to basically just deploy to any enterprise user, but that's beyond the scope of this webinar here. In terms of UI kit, you have a lot of different controls that you can use to create your user interface, and you can just review them here. That's basically a decent toolbox, but sooner or later you're going to want to use more of those. So Cocoa Controls is one of the main sites where you can get a lot of open source and commercial controls. So you just go to cocoacontrols.com. If you want the Various also has a UI component store. If you want different map kits, Google has reintroduced an SDK for iOS. Esri and Bing Maps also have free controls for iOS. And of course, Infragistics, being a component vendor, we're actually the first vendor to introduce premier enterprise class controls for iOS developers, and this works both for native iOS development with Objective-C, but also C# development with Xamarin Monotouch. So these are just some of the popular Cocoa controls that you can get for free on cocoacontrols.com. They're all very simple little UI widgets. So as you can see, things like simple calendar control, gradient buttons, circular progress and things like that. If you want more advanced controls, though, I would highly recommend that you try our iOS controls here at Infragistics called Nucleus. You can go to infragistics.com/iOS to get access to product information there. We basically introduced our first release in 2012. Our data chart today already has over 22 data chart types. We're introducing a whole bunch of new ones in April. We have a grid control that's also available today that can be used both as a data grid or a layout tool. And in April, we're introducing a new radial gauge, pie chart, new chart types. We have a rich text label, full monotouch support, full documentation for everything. So definitely make sure to check it out. So I'm going to browse through pretty quickly here. If you have an iPhone or an iPad, go ahead and download a sample browser. It's a free application in the Apple App Store that allows you to basically play with our controls, see them in action. So if you just go to bit.ly/IGIOSSB sample browser, you can basically play with our controls and see them in action. They're pretty phenomenal. Our grid offers a lot of different features. I'm not going to go through them in detail here, but it basically allows you to create all sorts of advanced applications. All of these were done with our grid. It could be more like a data grid, or it could be even like a layout tool to create these bookshelves of movies or books like you see here. And you can also integrate a chart and a grid together, as you can see here. The chart, we have over 22 chart types. We have more chart types that are coming in 13.1. So we'll basically have 40 chart types by April. So making it the best chart control for iOS developers. So these are just some of the few chart types that are available today, and they run both on iPad and on iPhone, so it's definitely a premium set of controls. iOS 6 introduced a whole bunch of new features. I don't really have time to review them right now. You can look at the deck. There's also a lot of videos from last year's Apple Worldwide Developer Conference, so you have the URL right here if you want to look at them. So next steps, let's wrap this up. We're already a couple minutes overboard, so I apologize for the delay here. To get ready to become a developer, an iOS developer, so register for a free account. Just a free account is going to be enough to get access to the documentation, to the downloads, to get Xcode installed. And you can see this at developer.apple.com. Get a Mac machine and then install Xcode for free from the Apple Mac Store. To learn more about iOS, there's official getting started videos at developer.apple.com/video/iOS. The Worldwide Developer Conference videos are also available. Pluralsight, one of Infragistics' partners, has a bunch of iOS training videos, some from 2011, some from 2012. So you can see here a link for this. If you want to follow a bunch of iOS experts and people that tweet and blog about iOS, I maintain a list on Twitter. So on my account, ActiveNick, go to /iOS-dev-bloggers, and you will see a bunch of people there that if you can just follow that list, you will basically be hooked up with a bunch of people that talk about iOS. If you want to get free open source controls for your little widgets, go to cococontrols.com. And then, of course, to get powerful professional level controls for your applications, go to Nucleus at infragistics.com/iOS. There's a free evaluation for the controls, so there's no investment up front. Try them for yourself. It's definitely worth it. And beyond this, I'm including a few books here, so when you download the slide deck, you'll be able to see all those references. So these are great books to help you get started. The Big Nerd Ranch guides are some of the best ones available on the market today for iOS development. There's also Josh Smith has another book, more for .NET developers, and then the A-Press book is also a very good one. It's actually more on iOS 5, though. It doesn't cover the latest iOS 6, but all these books get new editions. There are free iBooks available on the iPad bookshelf as well. Most of them are iOS 4, though, because they date back to 2010. So, yes, it's good. They're free, but unfortunately, there's a lot of things that might not be included in there, especially like automatic reference counting. That was added to iOS 5, so you might not find this. Actually, you will not find this in any of those books. If you're interested in more mobile development, I will be doing another mobile development webinar this Thursday, so in 2 days. It's going to be at the same time at 11 a.m. Eastern Time. So you can just go and register at bit.ly/WP8webinar. And that's how you can register for this webinar. So I hope to see you back here so that you can round up your mobile development skill set with not just iOS, but also the Windows Phone side of things. So that's it for me. So thank you very much for joining us today. I apologize for running a slightly overboard here. So hopefully Brent has been able to answer a lot of your questions along the way. I will be looking at the questions now and continuing to answer some of them. My blog is at activenic.net, so I'll be posting the slides and demos on my blog this week. You can follow me on Twitter at activenic. If you have any questions about this material, the webinar, and things like that, you can contact me at activenic@infragistics.com. You can check out my apps at this URL. And of course, go to infragistics.com to check out our products. Or you can also go and like us at facebook.com/infragistics and follow at infragistics on Twitter. So thank you very much for joining us today for this webinar on iOS development for .NET developers. And now let's go and look at some of the questions that might have popped up. So let's see here. Questions. I'm going to increase the UI size here so I can see all of this. So I'm going to put the last slide here. Okay. All right, so let's maximize this. So we have some questions that have been asked here. Let's see. I guess there's been a lot of questions that have been answered already. So I guess there's only... So it's not really WCF services in terms of native iOS applications. You will be simply calling REST services. So there's a lot of chapters and books that cover this. You can call, of course, a WCF service that exposes a REST endpoint, so that's not a problem. But remember that for a native iOS application, you're coding the client side of things, not the server side of things. Okay, question here. Thank you. Okay, I was just curious, why would a .NET C# developer doing a few iOS apps for business would use Objective-C as opposed to MonoTouch if their employer will buy it? Yes, you can use MonoTouch anytime if you want to use that. That's not a problem. It's a very viable option. It's simply that some people, of course, prefer to use the native way of doing things. All the innovations also come from Apple on the Objective-C side of things. So MonoTouch, of course, tries to keep up in the background, but it's all about having different options. I strongly believe that a good developer should understand the native way of doing things on a platform first. You're also going to find a lot of books and a lot of resources and a lot of coverage online on places like Stack Overflow using Objective-C. So it's going to help you communicate with other iOS developers a lot better. Consuming REST services from iOS, unfortunately, I don't have time to cover this in this book right here. It is entirely possible using the framework libraries, but I just don't have time to cover it in this webinar. Good SOAP wrappers clients that I know of, I don't really have an answer for you on this one right now, unfortunately. As I said, everything about calling services on the server is something that goes beyond the basics here. What we can always do is we'll probably run more webinars later, and then we can cover more advanced topics for the enterprise like this. So a good strategy for C# is how to read Objective-C for plugin wrappers for MonoTouch. So whenever you create applications with MonoTouch, you basically create them using C#, and your controls that you're going to be using, for example, already are going to have native wrappers. But let's say that you want to create your own wrappers. That's where having better knowledge of Objective-C and Xcode is actually going to help you. And security in iOS apps. I'm sorry, we don't have time to cover advanced enterprise topics. This is an introduction session right here, so hopefully this helps people get started. The deck will actually be posted on my blog, activenic.net. That's the site. You can already download a previous version of this deck anyways, because I've done it in other sessions before. So if you look at any of my past posts from prior events like VS Live, you'll be able to see the deck from those sessions, and it contains the same information. I will make sure to post this deck so that everybody can see it, and you'll be able to get all the references in there. Definitely take a look at the Big Nerd Ranch guides, the one for iOS programmers, and it's going to cover a lot of more advanced topics that we just couldn't cover in this 1 hour today. Okay, what hardware would you like to suggest if I don't want to reinvest in hardware again and again? Um, well, in terms of hardware, as I said at the beginning, there's a few options that are available. You basically can use you can go buy used hardware if you don't want to invest too much. So you can get a used MacBook Air from a one generation or two ago for less than $1,000. You can get a brand new Mac Mini for about $1,000 as well. The beauty of the Mac Mini is that it's just a machine you get. You don't get the screen or anything, so you can reuse existing hardware that you might have to connect to your Mac Mini. So that's a good starting point. And then you can also work and upgrade a few things from there. But a Mac Mini is kind of a starting point. So take a look at it. The Mac Mini is under $1,000 US. Unfortunately, I don't have the information in terms of how much it would cost in other countries. We can also look at it. Yeah, there are services like Mac and Cloud and things like that. So there's definitely been a lot of people spending a lot of energy trying to find ways to build applications without a Mac. But sooner or later, you're going to run into some problems because you'll want to deploy it to an actual device. You'll want to be able to build yourself. There are cloud services you can take a look at. So definitely you can take a look at this. But I definitely recommend getting a Mac. If you're just trying to get started, you can also borrow maybe a Mac from someone. Then you'll see if you'll want to stick with the whole iOS development thing. If you're doing it for the enterprise, then make sure that you educate your management into the need for an actual Mac machine. So I guess that about wraps it up for this webinar. So let's stop things here. So thanks again to everyone for joining us today. And remember to join again for the webinar series. Go to infragistics.com to follow information about our products and future events. And also remember to log in on Thursday for my next webinar on Windows Phone development. Thank you and have a great day.